Hello everyone. Today let's learn about the subject psychrometric chart, which comes under the post-harvest operation drying. This topic has been taken from the course post-harvest engineering of cereals, pulses, and oilseeds. First of all, let's have a look at some facts and terms concerning the topic. Psychrometry. Psychrometry is concerned with the determination of properties of gas-vapor mixtures, or it can be described as a field of engineering concerned with the physical and thermodynamic properties of gas-vapor mixtures. Let's get familiar with some terminologies in psychrometry. The first one is dry bulb temperature. It is the temperature of air determined by a thermometer with a dry bulb. The second is wet bulb temperature. It is the temperature of air which is measured by a thermometer with a bulb covered by a piece of wet cloth. It is observed that at 100% relative humidity, the wet bulb temperature is equal to the dry bulb temperature, and it is lower at lower humidity. Next is dew point temperature. It is the temperature to which the air must be cooled to become saturated with water vapor. Next is absolute humidity. It is a mass of water vapor divided by a mass of dry air in a certain volume of air at specific temperature. Relative humidity, the ratio of actual vapor pressure in air vapor mixture to the saturated vapor pressure in air at the same temperature. Percentage humidity, the ratio of absolute air humidity to absolute air humidity at saturation point. Saturated pressure, it is a water vapor pressure of saturated water vapor. Humid heat, it is a specific heat of humid air expressed in per unit mass of dry air in the mixture. Humid volume, it is a volume occupied by a unit mass of dry air and its vapor at the given temperature and pressure. Enthalpy is the total heat content of air vapor mixture. The enthalpy can be calculated by the equation. The equation is Ig is equal to 0.24 T plus HHG, or Ig equal to 0.24 T plus 597.3 plus 0.45 T whole into H, where Ig is the enthalpy, T is the temperature, H is the absolute humidity, and Hg is the heat content of 1 kg water vapor. The last one is adiabatic process. It is a process in which there is a change from one condition to another condition without transfer of heat between system, atmosphere, or surrounding during the entire process. Now we are got familiar with the terms commonly used in psychrometry. This will further help us understand the features of a psychrometric chart. Psychrometric chart. A psychrometric chart is a graphical representation of thermodynamic properties of air. In this chart, the absolute humidity, percentage humidity, humid volume, enthalpy, and adiabatic saturation lines are drawn against temperature. The following thermodynamic properties of moist air at 1 atmospheric pressure is given in a psychrometric chart. They are wet bulb temperature, dry bulb temperature, dew point temperature, humidity ratio, relative humidity, specific volume, and enthalpy. The wet bulb temperature is indicated by diagonal lines in a psychrometric chart. In this figure, the green lines represent the wet bulb temperature. Next is dry bulb temperature. The dry bulb temperature are represented by vertical lines in a psychrometric chart. Here the blue lines represent the dry bulb temperature. The relative humidity is represented by curved lines in a psychrometric chart. It is usually represented in percentage. Next is dew point temperature. It is represented as shown in the figure. The enthalpy or heat content lines are represented as shown in the figure. The specific volume is represented in also as diagonal lines. They also increase from left to right. Next is the psychrometric processes that we're going to learn. The first psychrometric process is sensible heating and cooling. The sensible heating process means the increase in temperature of air without changing its moisture content. Also, the sensible cooling is a process in which the sensible heat is removed, and thus there is a decrease in temperature. In this process, there is no change in moisture content. The points to be noted that for the first one is dry and wet bulb temperature, the enthalpy, the specific volume, and relative humidity changes during this process. On the other hand, there is no change in humidity ratio, dew point temperature, and vapor pressure. The representation of a sensible heating and cooling process is as shown in the figure. In this, the line starts from initial dry bulb temperature of air and ends at the final dry bulb temperature. It extends towards the left side during a sensible cooling process, and vice versa for the sensible heating process. The next process is heating with humidifying. In this process, usually in drying systems, the not only heat is given to drying air, but also some amount of water vapor. During this process, there is increase in enthalpy, humidity ratio, water vapor pressure, dry and wet bulb temperature, dew point temperature, and specific volume. On the other hand, there is a decrease in relative humidity of air. This process is represented as shown in the figure. The third process, cooling with dehumidifying. During this process, there is decrease in values of relative humidity, dry and wet bulb temperatures, enthalpy, and specific volume of air. The representation of the figure is as shown. The fourth one is drying. In columnar dryers, the drying is usually assumed to be an adiabatic process. So the sensible heat is converted to latent heat during this process. Therefore, there is an increase in water vapor content. During this process, there is a decrease in dry bulb temperature, increase in humidity ratio, relative humidity, water vapor pressure, dew point temperature, and the point is that in adiabatic drying, the wet bulb temperature and enthalpy are constant. The representation of drying process is as shown. The fifth process, mixing of air streams. In this, let us consider two air streams having the flow rate M1 and M2, humidity ratio H1 and H2, and enthalpy Ig1 and Ig2. After mixing, we can derive that M1 plus M2 equal to M3, M1 plus M1 H1 plus M2 H2 equal to M3 H3, M1 Ig1 plus M2 Ig2 equal to M3 Ig3. Or from this we can derive H3 is equal to M1 H1 plus M2 H2 by M1 plus M2, and Ig3 is equal to M1 Ig1 plus M2 Ig2 by M1 plus M2. The representation of the process mixing of two air streams is as shown. Now let's move on to some problems regarding the drying. This will help us to make use of a psychometric chart. The first problem is, if the dry and wet bulb temperature of moist air are 35 and 26 degrees Celsius respectively, find the other thermodynamic properties of air from the psychometric chart. For this, we will need a psychometric chart. The commonly used psychometric chart will look like this. So in this chart, first of all, we have to identify the condition for the question. From the question, we get that dry and wet bulb temperatures of moist air are 35 and 26 degrees Celsius. So we have to plot the point in a psychometric chart. The 35 degree point from the dry bulb temperature and the wet bulb temperature 26 degrees Celsius. So that we'll get a point like this. That meets both the wet bulb line and dry bulb line. From this line, we have to identify the relative humidity, enthalpy, etc. So as a result, we get the answer as relative humidity equal 50%, humidity ratio 0.0174, dew point temperature 23 degrees Celsius, and enthalpy 90.2 kilocalorie per kg, and humid volume 0.897 meter cube per kg. So that's the end of the first problem. Now let's go on to another problem. The question is, paddy is being dried in a bin. The dry and wet bulb temperatures of ambient air are 30 degree and 22 degrees Celsius respectively. The relative humidity of exit air is 80%. If the heated air temperature is 50 degrees Celsius and its flow rate is 30 meter cube per minute, calculate the amount of sensible heat required to raise the temperature of air. Also determine the water vapor removed per hour in the drying operation. From the question, the first condition is the dry bulb temperature 30 degree and wet bulb temperature 22 degree. So that will get a point on the psychometric chart as like this. At this point, what we have to measure is the humid volume. So we'll get the humid volume as 0.877 meter cube per kg. The humid volume is seen at the left right end of the chart. So that the mass flow rate of air equal to 30 meter cube per minute into 60 minutes by 0.877 meter cube by kg, and we'll get the answer as 2052.4 kg air per hour. The second condition in the question is, the heated air is heated up to 50 degrees Celsius. So that from the psychometric chart, we get another line by moving horizontally from the first point till it reaches 50 degrees Celsius dry bulb temperature. So that will get a point like this. At this point, not only at this point, we have to measure the enthalpy at point 1 and point 2. at point 1 we'll get it as 15.4, and at point 2 it will be 20.3. So that the amount of heat required for drying is given by the equation Q equal to m delta H, where m is the mass flow rate of air and delta H is the enthalpy change. So that we'll get the answer as 10,056.7 kilocalorie per hour. The third condition from the question is that the relative humidity of exit air is 80%. We have to assume that the relative humidity is constant, and we have we have to move to the relative humidity line 80%, and where it makes the wet bulb to get a point 3, which is marked by green color. At this point we have to measure the humidity ratio at point 2 and point 3. So we'll get it as 0.013 and 0.0218 at both the points. So the increase in humidity ratio will be equal to 0.0088, and therefore when the 30 meter cube per minute air flows, the mass flow rate will be equal to 18.06 kg per hour for the water vapor. And that's the end of our problem. We get the solution. We'll get the solution as prescribed in the question. Similar problems can be solved using a psychometric chart. So now I hope all of you guys are well versed in using a psychometric chart. This knowledge will help you learn about more subjects in drying and other properties of air gas mixtures. So keep searching for more knowledge, and thank you for watching. Thank you.